planar graph. A graph is called planar if we can reconstruct that graph without any edge crossing. And such a drawing is called a planar representation of the given graph. Suppose we have this graph. We need to identify whether this graph is planar or not. So right now there is a crossing of edges. So it means we need to reconstruct this graph in such a way that there is a no crossing of the edge. So in case you can do that, it means the given graph is a planar. Let's try to reconstruct this graph without crossing of the edge. As these two edges are crossing, so we have considered one edge as it is. Now we will reconstruct the second edge. So we can start this edge from here to here. So with this, there is a no crossing of the edges. It means the given graph is planar, and this is called as a planar representation of the graph G. And we can say that yes, the graph G is planar. And the justification for your answer is that planar representation. Next is we need to check whether Q3 is a planar graph. Q3 graph is look like a Q. So we need to reconstruct this graph in such a way that there is a no crossing of the edge. Can you do that? So there is a crossing of the edges in these two one, even in these two one. So we need to remove this intersection of the edges. For that you can take the front face of this cube as larger than the back face of the cube. So now we will connect these two vertices over here and these two vertices, then these two vertices and then these two vertices. So this is the one way to reconstruct the graph Q3 in a plane without crossing of the edge. So this is basically a planar representation of Q3. So it means yes, Q3 is planar graph. Because we can reconstruct this graph without crossing of any edge. Next is K5 planar graph? So K5 is a complete graph with the 5 vertices. We need to identify that whether this is a planar or not, means can you reconstruct this graph without crossing of the edges? Let's try it. So for reconstruction, we have considered the boundaries and these two edges. Next, we need to reconstruct these three edges. So for this, the yellow edge can be taken from the outside. Same for this edge. So we can again take this edge from the outside. Next, we need to take the white color edge. So white color edge is between this vertex and this one. So let's try to reconstruct this without crossing of the edge. So one way is we can go directly. So in this case, there is an intersection with this edge. So with this, we are getting the intersection between the edges. Let's try in another way. So if you start that edge from here and you're moving from the outside, still there is an intersection with this edge. It means we need to try with some another way. So let's try to move from the outside, from the upper side. From upper side, still we are getting the crossing of the edges. So there does not exist any other way to reconstruct this graph so that there is a no intersection of the edges. So therefore we can say that K5 is not a planar graph. So when the graph is not planar, it is also called as non-planar graph. So we can say that K5 is a non-planar graph. So this is the application of the planar graph. So in this case, we have considered the 3 houses and there are 3 separate utilities. Now the question is, it is possible to join these houses and utilities so that none of the connection cross? So let's try to answer this one. First, we will model this problem into the graph. Once you do that, you will get a complete bipartite graph K33 where these vertices represents the houses and the bottom vertices represent the utilities. Now we'll rephrase this question. The question is now, is this graph is planar? Or the question can be rephrased as, is this possible to reconstruct this graph without crossing of the edges? Let's try it. So we can reconstruct this graph by removing the crossing of the edges. While reconstructing this graph, you can observe that these three yellow edges are as it is. These three red edges, one is as it is, second is taken from this side. Now we need to take this edge. So we can also reconstruct this one from this way, and still there is a no crossing of the edges. Now there are a three pink edges. One is as it is and second is taken from the outside. Now we need to reconstruct this one. Can you reconstruct this edge without crossing of the edges? One is directly from this one. There will be a cross over here. Let's try from the another way, because with this there is a crossing of the edges. So if you try from the outside, still there is a crossing over here. So if you are coming from this side, still there is a crossing of the edges. It means we are not able to reconstruct this graph without crossing of the edges. So we can say that the graph is non-planar. So K33 is a non-planar graph. So if K33 is a non-planar graph, then for the original problem we can say that there is no possible way to join these house and utilities so that none of the cross section is there. So answer in this case is no. So this is how the practical problems are modeled into graphs, and after that with the help of the concept of graph they are answering the original complicated problems.